Today is a review of all those important special triangles that we have learned about so far. So there are two types of special triangles. The first type of special triangle we have, it starts with a square. There is a diagonal drawn, and we get a triangle where the sides are x, x, and x square root of 2. Across from the angles 45 and 45. So this here is the relationship between the sides and the angles in a 45, 45, 90 triangle. Now the second type of special triangle that we learned about was the 30, 60, 90. So here we have 90, here we have 60, and here we have 30. The side across from 60 is always going to be y square root of 3. The side across from 30 is always going to be y, and the side across from 90 is always going to be 2y. So the angles that we use here are 30, 60, and 90. Now let the angles be your guide. They tell you where the sides go. And if you're just given the sides and you're looking for the angles, the sides will tell you where the angles go. So it's very important. If you see a 45 in a triangle, you will know that this is the triangle that you use to solve it. If you see 30 or 60 as the degree measures in a triangle, you will know that you need to use this triangle to solve it. Let's do the following two problems. In the first problem, it says, the perimeter of an equilateral triangle is 39 centimeters. Find the length of the altitude of the triangle. So let's draw our equilateral triangle. Now the problem tells us that the perimeter is 39 centimeters. Now remember, we always divide by the number of sides if the sides are equal in order to get the perimeter and find the length of each side. So 39 divided by 3 gives us 13. So the length of each side here is going to be 13. Now the problem asks us to find the length of an altitude. So we need to draw that altitude. And now we have 30 here and 30 here. These are 90. We have a 30, 60, 90 triangle. So let us draw a guide triangle. Over here, we have 90 here. This is 30, and this is 60. The side across from 30 is y, the side across from 60 is y square root of 3, and the side across from 90 is 2y. I'm going to let my guide figure show me where to put the information on the original figure. So this side here is 2y, this side here is y square root of 3, and this side here is y. Now I find the number on the figure, they give me 13 equals 2y. This becomes my equation. Divide both sides by 2, y equals 7.5. So everywhere I see a y in the figure, I plug in 7.5. And has it become obvious what the length of the altitude is? Yes, the length of the altitude is right here, and it's 7.5 times the square root of 3. Let's try this one here. It says the length of an altitude, so now they give us the length of the altitude, of an equilateral triangle is 12 feet. Find the length of a side. So we have equilateral triangle here. They tell us there's an altitude. So we know all about the degree measures of the angles now, given the altitude. They tell us the altitude is 12 feet. So this here is 12 feet. I draw my guide triangle. And I just copy the degree measures from over here. Once I know the degrees, I know the sides. 30 is across from the side y, 60 is across from the side y square root of 3, and 90 is across from the side 2y. I put this information into my figure. I get 12 equals y square root of 3. This side here is y, and this side here is 2y. I look for the number in the figure, and that becomes my equation. I solve this over here. 12 equals y square root of 3. Divide by the square root of 3, divide by the square root of 3, y equals 12 square root of 3 over 3. Y equals 4 square root of 3. So now I put that y value back into the figure. Y equals 4 square root of 3. 2y equals 2 times 4 square root of 3, which gives me 8 square root of 3. And this side here is 12. So they're asking me what the length of each side is. Well, I found the length of this side to be 8 times the square root of 3. It's an equilateral triangle, so all sides are equal. Therefore, the length of a side equals 8 square root of 3.